Worksheet 5.1, we're just going to go over the front. Make sure you feel good about it. And again, by the end of tomorrow, we will check that off, so you need to physically show me. So problem number 1, which mine's cut off a little bit, but they want us to show the F prime chart based off of this graph. So let's see, we have -3, -4, +1. So this kind of comes up and does one of those kind of. All right. So if we're going to complete this chart, remember F prime deals with the slope of the tangent line. So right here, this is positive, then this is supposed to be at 1. That's right there. This is negative, and that's positive. So put those values that are going to help you. So you probably get away with saying -3 and +1. And then you could say that you have a positive slope here, a negative slope here, and a positive slope there. And that's all it is. So the F prime chart is just based on what the slope is doing. Remember, F prime is the derivative. The derivative deals with the slope. That's how you do that first problem. Okay, hello. We're on worksheet 5.1, and we'll be checking it off tomorrow. So. So does that make sense, friends, how we did the F prime chart? So remember the F chart, which we don't use too often, the F chart is just basically where it's above or below the x-axis for the positive and negative. The F prime chart is dealing with the slope. So the slope here is positive, the slope here is negative, slope here is positive. So you just list those characteristics on your thing. You don't really have to have the -4 on there. That was extra information. If you put it, it's kind of wrong on the F prime chart because you don't want to show a positive, because if you showed a positive, it means you'd have a point of inflection that would have taken place someplace in there. All right, can I move on? We good? Number 2, they gave us the F prime chart. And we have -3, 1, and 4. And so we go negative, negative, and then positive, positive. How many points of inflection would this particular one have? It would have 2. So because you have this is a point of inflection, and there's a point of inflection here. So we were trying to make this graph the best we can, throw in the values in that we know. Oops, that's a 4. Okay, so this means we would add a kind of something like this. So this and this are your points of inflection. I mean, I'm off a little bit because I can't draw real well. But that could be one way that the picture would look. Oh, I take it back. I'm wrong on my picture. This is wrong. Okay, so kind of. Hang on. I know what I'm going to do to make it easier. Okay, this eraser clearly stinks. All right, so let's draw what it's going to look like, then we'll put it in. So we're going to have something like that, and down, and back up. So something like that. Okay, let me see. Did I do that right? So at -3, you have a point of inflection. At 1 is where it switched directions, went from negative to positive. And then at 4, you have another point of inflection. So that's an okay way of drawing it. Did I do that right? Negative, negative, and then positive. Yes, that works. Cool. And then number 3, they want us to make the F prime chart. Oh, that's going to be an easy F prime chart. So you're just basing it off of this parabola. So at 3, so our F prime chart for this, we're just going to put 3 right here. And we're going to go positive to negative, and that's all you have to put. So that's a really small F prime chart. Those are roots. They're not changing the direction of the graph. That just happens where they cross the x-axis. Cool. And then number 4, we can go ahead and find the roots. I would just jump onto Desmos to verify what they're going to do. So we got y equals 2x raised to the 3rd power plus 9x raised to the 2nd minus 5x. And we want to do the roots. So the roots of this are where it crosses the x-axis. So our roots are at -5, 1/2, which is the same thing as 0.5, and at 0. So there's our roots. And then if it says, where are the intervals increasing or decreasing? So what you need to do at that point is you have to find your local maximum and your local minimum. Okay, so don't worry about not knowing what the fraction is. So I'm going to write this down. So -3.25 to 0.25 decreasing and 0.25 to infinity. There we go. Increasing. All right, so based off this, the local minimum and local maximum, we can show where it's increasing or decreasing. So for number 5, or number 4, excuse me, if we had this equation, and I imagine there's a way this would have factored out, but I'm not worried about factoring because we have Desmos. So it is increasing from -infinity to roughly 3.25. It's also increasing from roughly 0.25 to infinity. And then it's decreasing in between those two, -3.25 to roughly 0.25. And again, it's fine if we're using the estimates, being we have Desmos as our fun thing. And then number 5 says, graph the intervals where f of x is increasing or decreasing. But they gave us the derivative. And we haven't taught about antiderivatives yet. So they gave us this equation. Okay, so this is the derivative. This would have been a pretty nasty derivative to take. It looks like it's using the chain rule and the product rule all in one. So where would this be increasing or decreasing? So what I'm going to do is I'm going to solve each of these. So if I have -2x equals 0, so x equals 0, so that's one of our critical values. Then I get x minus 3 quantity squared equals 0. So x minus 3 equals 0, so x equals 3. That's another critical value. And then x plus 4 equals 0, so that's at x equals -4. So what we can do is we can make our f prime graph and plug in our critical values, so -4, 0, and 3. Okay, so how can we decipher where it's positive, negative, what's going on, is there a point of inflection in there, things like that? And we're not sure yet. So what I would do is an easy way to do this is pick a large value. So let's pick, say, 100. All right. So this is what we have to do. If we're picking a large value of 100, does everyone agree 100 is way out here to the right? Okay. So you don't really have to do the math to make it work. So 100 plus that, 100 minus that, square that. If I multiply these two values together, even though they're really big, this would give us a positive answer. And then -2 times 100, well, a negative times a positive is going to be a negative. So the values way out here are negative. Okay, I didn't have to actually do the value. I just kind of had to make it work in my head. And then we can say, okay, what's taking place between 0 and 3? So we're going to pick a value like, excuse me, pick a value like 1. So if I plug 1 in, the middle, x minus 3 quantity squared, has got to be positive. The x plus 4 has got to be positive. So positive times positive is positive times a negative. So we have a negative here. So what is 3 on this problem then? It's neither of those. I have 2 negatives in a row. So what does 3 have to be?
0.
Oh, it does come out 0, yes. But if you get 0 for a slope, that's a horizontal line. So 3 is actually a point of inflection. And then if we plug, say, -1 into this, if I plug -1 into the middle part, that's going to be positive. If I plug -1 in here, that's positive. If I plug -1 in here, that becomes positive. So positive, 3 positives in a row multiplied together gives me a positive. And then if we pick, say, a really small value, so if we pick like -100, this is going to be negative, this is going to be positive, this is going to be positive. So positive times negative is negative. So now you're able to get your sign line. Again, you don't have to find the true value of it. You just have to think about what the sign would be for each portion, and you're multiplying the portions together. And so now we need to do the intervals so we can do that. So our intervals for increasing is where it's positive. So that's from -4 to 0. And our decreasing is all the negatives. So -infinity to -4. And then from 0 to infinity. Notice I take it back. Can't be that, because the point of inflection is a slope of 0. So 0 to 3, and then from 3 to infinity. And being you listed that 3 twice, that means that there was a point of inflection that took place there, meaning where it would have been the wiggle. Cool. Any questions about those? So it's just a different way of thinking about what a function would be looking like if we did not have anything else. So we will go over, but I'd like to give you the opportunity to work on it. And you guys want a quiz this week?
Sure.
I have to see if I have a quiz. I don't know if I have a quiz. If I do, so finish all of the worksheet 5.1. So that's including the back page as well. And if you need any help, happy to help you. Deal?